Be the review for the quiz on linear systems, graphing linear systems. So I want to start with the back of the review packet because I figure that if you can do the word problems, it should make doing just the plain equations a little bit easier. And for the keystone test, you definitely need to know how to do word problems. So let's focus on these first. So we have Lisa is competing in a bicycle race. She's traveled 12 miles and is maintaining a steady speed of 15 miles per hour. So that's one situation, right? Lisa's. So if we try to write an equation for Lisa, we'll start with that idea. It's always going to be a y equals mx plus b equation. So if we think of it this way, there's going to be one value that is going to be the same and one value that's going to change. So I think if you look at it like this, the 12 miles is what she's already done, and that's not going to change. What is going to change is, based on the number of hours, she's going to be adding 15 miles every hour. So I think it's the 12 that would be by itself, and the 15 that would get the variable. So this says that based on the number of hours, you put in the number of hours here, and it would change. So let's do the other one then, which is Mike. And he's doing 8 miles and then does 18 miles per hour. So we have the same kind of format and we'll follow the same reasoning. Mike is going to have 8 to start and then he's going to go 18 for every hour. So we need to graph these two equations and find out where they intersect. That intersection will help us figure out the answer to these two questions here about how long will it take Mike to catch Lisa and how many miles will they be when they meet. So we'll work on that. So x is hours and y is miles. Okay, so let's go to the graph. Looking at the equations we have to graph, it looks like maybe we ought to consider doing them by twos because of how much change they're going to have here and because of how big these start. So I'm thinking that maybe we should do the y-axis in twos. So the y-axis is miles. We'll make it by 2. So we go up to 30, and we might have to go higher. I guess we'll find out. X is the number of hours they ride, and I think here we can just go by ones like we normally would. There's 5, 6, 7, 8, 9. I'm going to stop at 10, and again, if we need to go bigger than that, we can. So I'm going to put Lisa's equation in red. Y equals 15x plus 12. I'm going to put that on the graph. The plus 12 part is a y-intercept. That means the graph should start at 12, which is right here. And then I need to go for a slope 15, which is 15 over 1. So from the 12, I have to go up 15 and over 1. So I'm thinking that's 2, 4, 6, 8, 10, 12, 14. Up another one would be 16, so right in here, up 15 and over 1. That graph is going to be right here. I'm going to zoom in on this for you a little bit so you can see it. So you can see how I put a point here for 12, and then I went up 15 places and over 1 for the slope. And then I'm going to connect those two lines, trying to draw it straight through the middle of the point so that I can be as accurate as possible. But this would be Lisa's graph. As you can see, it keeps going up and up, and it's pretty steep. I think what we're going to find is that Mike's graph is going to be even steeper yet, but it's going to start at a lower spot. So we have y equals 18x plus 8. And so his graph needs to start at 8. So here's 10. 8 is right in the spot below it, right here. And I need to go up 18 and over 1 then. So from here I'm going to go up 18 places. 2, 4, 6, 8, 10, 12, 14, 16, 18 and over 1. Right here. So again, we see a pretty steep graph. And that pencil broke, so I'm going to just color this back in with my regular pencil too. See, what we see is that the two graphs are so steep that they almost look like they're the same line. But if you look at the top of this thing, you can see where the blue one starts to get even steeper than the red one. It looks like the answer is right here, where the blue and the red one cross each other, right at this spot. Which means that it looks like x is 1, and that would make y about 26. So let's see if that's actually the right answer or not. I'm thinking that might not be exactly right, but let's take a look. If we go to the graph with y, the first one, if we put 26 in for y, and then it would be 15 times 1 plus 12. This is 26 equals, this is 15 plus 12, 27. So it's not exactly correct, but that's awful close. And that might be all we can do with a graph this steep. Let's see, if we try the other one, it's 26 equals 18 times 1 plus 8. In that case, it's 26 equals 26. So it actually works for that one. So we are off by just a tiny little bit for that point. But it looks like, to me, I would say that is the closest thing you're going to get to a correct answer, 1 and 26. Which means that if we look at the situation above, how long will it take Mike to catch up to Lisa? Just about an hour, maybe a little bit longer. And how many miles into the race will they meet? Somewhere around 26 or 27 miles. That's what your answer means. The number of hours and the number of miles. So after that point, Mike will pass Lisa and he'll be ahead of her for the rest of the race unless something else happens. Alright, let's go back to number 8 and number 9. And we'll try the same kind of logic. This one's talking about Verizon and a cell phone plan that charges you a fee of $8 and charges you $2 per day. So again, if you look at that, right, for the first one, they're going to make you pay $8, but you only pay it one time, and then the 2 per day is the one that gets next to the X, like that. So this is for Verizon. And then Sprint is the same concept, except theirs is $3 per day and only a $4 fee that they charge once. So if we go to graph these graphs, I'm going to graph the Verizon one in purple so you can see how we'll do that. But first I want to label the graph. I think in this case I see these numbers of 8 and 4. If I make this by ones, it's going to have 1, 2, 3, 4, 5, 6, 7, 8. 8's going to be all the way up here. I think I'm going to do this graph by 2's on the y-axis. So we have money on the y-axis, and I'm going to do it by 2's. 2, 4, 6, 8. Here's 10, 12, 14, 16, 18. This is 20. And I'm just going to continue to do the x's by ones. Because x is the number of days. Okay, so let's plot the first one. I'll do it in purple. It says it starts at a y-intercept of 8, which is right here. And then you're supposed to go up 2, that's only one block, right? 2 and over 1. So the graph for Verizon looks like that. So I'll just do sprints in regular pencil. This one says to start at 4, so up to 4, and then from there I need to go up 3 and over 1 according to my slope. So I'll go up 2, and then if I go up another whole block, that's 4. I don't want to go up that high, so I'll go up 2, and then I'll go about halfway for 3 and over 1, somewhere right in there. And it looks like the sprint graph looks like that. This one works out really well. You can see exactly where the intersection point is. The intersection point is right here. And so we need to come up with the coordinates for that. That would be over 4 and up 16. So that's our intersection. So the question is then what does that intersection mean? Well, again, x is the number of days and y is the dollar, so it would take 4 days and $16. So what day will the plans cost the same after 4 days? What's the cost? $16. And see, after that point it becomes cheaper to use Verizon even though you have to pay an $8 fee. So if you were using it for 5 days or 10 days or anything more than 4, it's actually better to use Verizon even though the fee is higher initially. So let's go to number 9. We'll approach it again with the same idea. Can we write our two equations? So we're looking for that same kind of pattern. So I see tank 1, 14 inches of water in it. It's going to start with 14, and then it's going to lose or drain 2 inches per minute. So the 2 is the thing that's going to change. So if we think about it this way, we write an equation here. What's the number that we start with that doesn't change? That's the 14. Then the thing that changes is the 2 per minute. But if I write 2x, that means I'm going to gain 2 per minute. So I want to actually write negative 2x because it implies that I'm losing 2 per minute. So it looks like in this case, y is the amount of water in the tank, and x is the number of minutes. So maybe we can go ahead and label our graph down here with x being in minutes and y being the water. So let's see if we can write an equation for the other part then. It says the other tank has 10 inches of water and it drains at 1 per minute. So it starts with 10 and then we're going to lose 1 per minute like this. So again, we'll have to graph these two and find their intersection. And once again, I see pretty decent sized numbers here for y-intercept, so I'm going to make the y's by 2 again. And we'll just do the x's by 1s again. So for this first one, it says to start at 14, which is right here, and then it's going to lose 2 every minute. So down 2 and over 1. So I'm going to go down 2 and over 1. Keep in mind the y's are by 2, so when I say down 2, 1 block is actually worth 2. And I'll draw my line in. So we'll do the other one where it says to start at 10, but we're only going to go down 1 every minute. So I'm not going to go a whole block because that would be down 2. So down 1 is about halfway, and then over 1. So maybe you can see that the tank that had the purple line there, it starts higher, but it loses water faster. So eventually, we find the spot where the intersection is. Looks to be right here. We'll have to kind of estimate that point a little bit. It looks like 1, 2, 3, over 3.5. So x is 3.5, and y would be 2, 4, 6, maybe 7. So what does this mean? It says how many minutes will the tanks contain the same amount of water? It looks like about 3.5 minutes. And there'll be 7 inches of water left in it. And then after that, the one that started at 14 will actually continue to lose water faster than the other one, and you'll see that it'll empty first. Okay, so those were some word problems with context behind graphing these things. So then what we thought we'd do is give you some practice just graphing some of these problems where you can graph them kind of from y equals mx plus b format, and in the worst case scenario you might actually have to rearrange an equation. So if we look at number 4, we're really in the same kind of problem that we had with those word problems. We have something that says y equals 2x minus 3. So actually, I think that's 2x plus 3. Sorry about that. That one is 2x plus 3. So for that one, I would say, let's put the graph at positive 3 for the y-intercept. And this is the slope. So when you put the 3 on the y-axis right here, then you would go up 2 and over 1 for the slope. So we need to graph the other one on the same axis, so we'll do that one in pencil. It says to start at 6 on the y-axis, and then this slope says up 1 and over 2. So you can see the intersection point is right there, and the coordinates of that intersection are over 2 and up 8. So your answer would be 2, 8.
Following students, please report to the guidance office. Shelby Simmons and Christian Lee. The guidance.
So I'm going to move to number 5. Number 5 is one where it's a little bit more difficult because you'll need to do a little rearranging first. So I'm actually going to do this on a piece of scratch paper because I want to make sure you can see exactly how I'm doing it.
Kristen Yannick, Alex Tolnight of the office at this time, please. Also a reminder, Mr. Smithley's 6th and 7th period, you will report to the library for your classes today. The library this afternoon will be open. Thank you.
Okay, so let's do the rearranging for the first equation. You see, you're supposed to have a y by itself, so what we need to do is get rid of this 3x. So if I just subtract it from both sides, that'll cancel and leave me with a y. And on this side, I should put the x first, so the negative 3x goes first, and then it'll just be a plus 0 on the end. And the same thing is true for the other one. It started as y minus x equals negative 4. And I just need to get rid of the minus x part, so I'll add it to both sides. And when I do that, this x should go first. It's positive. We won't write anything in front of it, just an x. and the 4 is still negative, so x minus 4. So it's these two equations that you're actually going to graph. Both of them are pretty easy. Let's do y equals negative 3x plus 0 first. We'll do that one in purple. So plus 0 means it starts right at the origin. And then negative 3x is negative 3 over 1, so down 3 and right 1 to the slope. So then we need to do the same thing for the other graph. Do this one in red. This one says a y-intercept of negative 4, so it would be down here at negative 4. And then the number next to the x is an understood 1, which means its slope is 1 over 1. So we go up 1 and over 1. It's actually right over top of this other point. So you can see that the intersection is actually right at that one coordinate point. So we need to figure out what its coordinates are, and we'd be done. If you go over 1 and down 3, that will be 1 comma negative 3.